How's it going, Eliminators? Today, we're going to be diagnosing a fuel supply issue and possibly an electrical issue on a Craftsman riding lawnmower that's had an engine swap. So let's get right into it. So I have this Craftsman riding lawnmower that came into the shop. This has had an engine swap on it. You're going to notice that it says Briggs & Stratton 20.5. And if you look, he has a 27 horsepower V-twin. So it's had an engine swap, but the engine swap was done 10 years ago. And up until now, he says everything has ran flawlessly. So I'm assuming that whoever hooked it up properly. If it was done last week and he was already running into issues with the engine running, then I would suspect maybe someone not hooking things up properly. But again, 10 years, no issues. So just to quickly go over the main complaints, my customer says he cuts about an acre. He gets about 20 minutes into it and the engine just starts to shut down. And I asked him, this is part of my diagnostic procedure, does it shut down quickly or slowly? And he says it shuts down slowly. That indicates to me that it's a fuel supply issue, because if it was electrical, for instance, the coils being grounded out due to, let's say, like a seat switch, right? So if you get off your seat when you're cutting grass, it grounds out your coils and shuts the engine off right away. The other complaint that my customer had was that he kept having to charge the battery after it would shut down. So now this is starting to get into electrical issues, because a battery shouldn't have to be charged after an engine shuts down if there's a fuel supply issue. So that leads me to believe that there could be, like I said, two issues, electrical and fuel supply. And he said he went to turn the engine over and it wouldn't start, and that's a brand new battery, it was fully charged. He then tried to start it again and it wouldn't turn over. He said he had to let it cool down. Then he said by the next day, the battery had already drained down and he had to put it on charge again. So that indicates to me that there could be what's known as a parasitic load on the battery. So a parasitic draw on a battery is basically any unwanted drain on the battery. So to help explain that, I've hopped into the truck and we're just looking at the glove box here. So imagine for a second that this glove box had a glove box light. So let's say there was like a little light up here. That light is operated off of the switch. So the switch tells the light whether or not it should be turned on or turned off, and whether or not it's going to be a closed or an open circuit. So just imagine that you have a defective switch, so that when you go ahead and close your glove box, the light stays on. Now you can't see the light because the glove box is now closed, and that creates what's known as a parasitic draw on your battery. Now, of course, on a vehicle, there's all kinds of electronic devices and modules that could cause a parasitic draw on your battery. And on a riding lawnmower, there's a lot less of those things. Just to get started, I'm going to show you how to perform a parasitic draw test, and then I'll show you how to find them. And the first thing we're going to be doing is coming over to the battery here with your positive hooked up. You're going to come to the negative, that's the ground. You're going to disconnect that. Coming over to the multimeter here, we're going to be putting the multimeter into the amps. So this is the amps area here. And what we're going to be setting it to is approximately 200 milliamps. I'm assuming that there is less than 200 milliamps. If it was a higher draw, let's say it was like a 300 milliamp draw, then you would have to go to the next one up. Now, before we perform the parasitic draw test, you should know that anything over 50 milliamps is going to indicate that you have a significant parasitic draw. So anything more than 50 milliamps is no good. Anything generally under 25 is considered okay. And just to give you a spec, if you have a 12 volt battery, a 50 milliamp parasitic draw will completely drain your battery in about 30 days. So about a month if you just let it sit there with that 50 milliamp parasitic draw on it. So how do you perform the test? Well, again, with the multimeter set to 200 milliamps, you're going to take your ground and you're going to stick it to the battery's ground terminal. And you're going to take the red positive and we're going to touch it to the ground cable. Again, the ground cable is not connected to the battery ground. And we're going to look at our multimeter, and again, it's reading under 200 milliamps. And we can see that we're getting a reading of about 1.3 to 1.4 milliamps. So we're well under the milliamp spec that they give you. Now, if you're testing a vehicle and you're noticing that the milliamps are spiking and then dropping back down and then spiking up again, it could be a security light that's flashing. Because a lot of newer vehicles, they have those security lights, and believe it or not, that little red LED flashing will cause a little bit of a draw on your battery. But again, that's not considered parasitic because it's supposed to be doing that. Now on a vehicle, it's going to be a lot easier to locate where that parasitic draw is occurring, because you're going to have a big fuse box and you're going to be able to go in and start pulling individual fuses, and you're going to be testing in between the negative and positive side of the fuse, and you're going to be looking for a draw. So like 99 out of 100 fuses should show no draw after the vehicle's been sitting for approximately an hour and it's gone into what's known as sleep mode. And then you'll find the one fuse, let's say it's your glove box fuse or something like that, and you're going to see that that has a significantly higher milliamp draw than all the other fuses. And then you can go ahead and, you know, change out the glove box switch or something like that, or, you know, the trunk lid switch, whatever it may be that is causing a light bulb to stay on. So how do you find a parasitic load on a riding lawnmower? Well, it is a lot harder because you're kind of going to have to start back tracing things. Just to go over some things that generally happen, there's going to be diodes in your magneto. So as your flywheel spins, you know, the magnet goes past a magneto. There's a bunch of copper windings in there, and then that's what recharges your battery. And a diode basically just acts as a one-way check valve. So again, you know, current only goes in one direction from the magneto back to the battery. If the diode blows out, you're going to get a backflow of current, and it's going to create a closed circuit in between the battery and the magneto where the current just keeps flowing, and that would be considered a parasitic draw. Now, one other thing I wanted to point out is this riding lawnmower does have an amp meter, and if we come over here, it also has an hour meter. But with the battery hooked up, if we go ahead and turn the key on, listen, hear it clicking? So the timer is working when the key switch is on, and when we shut the key switch off, it's grounding it out. So that is not creating the parasitic draw because it's not getting any power. So for instance, if the timer here was clicking when the key was in the off position, that means that it would be getting current with the key in the off position, and it would be sitting there clicking away, draining the juice from your batteries. But one of the main things that I see all the time is a short to ground. So there's going to be a wire somewhere that is going to have a piece of the insulation on the wire. It's going to be off, and the wires inside of the insulation are going to be exposed. Now that can happen by mice chewing on the cables. That happens all the time. Or it could happen, you know, just by a wire rubbing up against a piece of steel. So we can, you know, come down to the battery positive cable here, and you guys can see in there that, well, it's rubbing up against that sharp battery tray right there. That's a pretty sharp corner. So at this point, I've hooked the battery back up, and we're going to turn the key, and you can probably hear the fuel shutoff solenoid clicking. And if I go ahead and turn the key, the engine wants to turn over. Now, it's not turning over all the way because it doesn't have the amps to engage the starter because the battery is low. There's only showing about 12.3 volts or something like that. And the bigger the engine, you know, the more amps you're going to need. So again, this is a new battery. So what I'm going to do is I'm going to charge it, but I'm going to be removing the battery and setting it off to the side because I want to inspect the wires underneath, because my customer said that the one time when he connected, and I just have the ground hooked up loose right now. My customer said when he connected the ground cable, it got real hot, and he noticed that there was a little bit of insulation coming off of it, so he went ahead and taped it up. Now that right there means that these battery cables have seen better days, and you know, the battery positive cable could be the same, but maybe because he can't see it, doesn't notice that there could be some insulation missing off of that. Again, could be mice, could be anything. But one of the big things here is that we're looking for a short to ground. So a short to ground basically is just when a wire is exposed and it shorts itself out to a source of ground, which in this case could be the frame, and electricity always wants to take the path of least resistance. So if you think of, like, let's say the headlight circuit, and you had wires going up to the left headlight, so there's going to be a positive and a negative. If you had that positive wire touch the frame, then what's going to happen is instead of sending the current to power that light bulb, you're going to be sending current through the frame, and then it's going to go back to the battery, and it's just going to continue that loop, and there's no power going to be going to the light. So again, a short to ground can cause these issues. And he did mention that when he hooked up the ground cable, things started to get a little warm. And that right there tells me that there's definitely a short to ground. So when you're looking for short to grounds, you always want to start with the battery and then go from there. So I'm going to be removing the battery, and I'm going to be inspecting the cables, and we'll see what they look like. So the battery's out and I have it on charge. And like I said, I'm just going over all of the cables here. And this is the battery positive cable. There's not a whole lot of corrosion on it. It looks to be in okay condition, and it was looping down by where the steering column is. And I could show you what that looks like just by putting a video up on screen. So the battery cable was looping on the bottom there, and then when you move the steering column, it was kind of close. And if we come down to where that area was, check this out, exposed wires, we roll that around, check that out. So that's been arcing out probably for a while. So every time you would turn a certain direction, the knuckle on the steering column would come in contact with this battery positive cable. So the exposed wires right here on the battery positive cable, if that created a short to ground, that would cause what's known as an intermittent parasitic load. So those would be definitely hard to find, because if you did a parasitic load test and it wasn't shorted to ground, you're not going to get your parasitic load reading on your multimeter when you're testing your battery. But every time the bare wire touches the frame, right, so it's intermittent, sometimes it happens, sometimes it doesn't, then you would get your reading. There's a short to ground created on the battery positive cable, which creates a significant high amp draw on the battery circuit, right? So now, instead of supplying 12 volts to the hot side of the solenoid, you're supplying 12 volts from the battery directly to ground, and then it's basically just continuing that cycle. So again, a short to ground, electricity always takes the path of least resistance. So now you've created a closed circuit where there shouldn't be a closed circuit. So that's why he said, when he went to disconnect the ground cable, it was really hot. And that's why, because this was shorted to ground on the steering column, most likely, and he just didn't realize it because the battery is in here and then the battery tray is there. So that was, way up underneath there. And by removing the battery, we were able to have a look underneath there and discover that. Whenever that shorts to ground on the steering column, because that's connected to the frame, what you're going to have is current that would normally go from your battery positive to your solenoid, which is bolted right in here. So that cable goes down to what's known as the hot side of your solenoid. Now from that hot side, there's going to be a small wire that goes up to your key switch, and that's going to provide 12 volts to your key switch. And our short to ground happens before the solenoid hot side, which means that no current would be going to the hot side of the solenoid, which would mean that the key switch wasn't getting 12 volts. So when we turned the key switch and you heard the fuel shutoff solenoid click, that's because the key switch powers your fuel shutoff solenoid, which means that our fuel shutoff solenoid wasn't getting 12 volts either. So the fuel shutoff solenoid would have closed, and then at that point, the engine wouldn't have got any fuel, and the engine would have shut down slowly, just like my customer said. So I believe that right there is causing our fuel supply issue. And then let's say that he gets off of it and pushes it back to the driveway. He turns the steering wheel. When he does that, the battery positive cable backs itself away from the steering column and is now not being shorted to ground, which means the solenoid hot side is getting 12 volts, which means the key switch is getting 12 volts, which means the fuel shutoff solenoid is getting 12 volts, and then the whole starter circuit is working as it should. So, 12 volts from solenoid to key switch, which then powers the solenoid magnet, which then connects the battery positive to the other side of the solenoid, which is connected to the starter via this cable here. And then again, you saw what I showed you earlier where you turn the key and the engine wants to crank over, but it just couldn't because the battery was drained. So again, at this point, I'm going to go ahead and remove this cable. I might even remove the solenoid just to further inspect to see if there's any other cables that are in this condition. Then I'm going to go ahead and rip out the ground cable. Might as well check that one too. But I think I have officially diagnosed the issue as an intermittent short to ground, which caused a parasitic draw on the battery and also created a fuel starvation issue by cutting power to the fuel shutoff solenoid, allowing it to close, which prevented the engine from getting fuel. So like I said, I've removed the solenoid here just by removing the two 7/16 bolts, and I've gone ahead and removed the battery positive cable. Now this little red wire here, that is what sends 12 volts up to your key switch, and that is connected directly to the little eyelet here. So what I'm going to do is simply unplug this from that connector here, and then I can go ahead and replace this whole cable here. So I have a new battery positive cable here, but it's a lot longer. However, it is the same gauge, so it's the same thickness, and I've just marked it using a little marker. So I'm going to cut it to the same length as that cable, and then I'll end up putting one of these little eyelet connectors onto the end where I cut it there. So I have my new piece of wire here, and I've stripped the insulation off. I have a new little connector there, but before I hook any of this up, I'm just going to put some heat shrink over that cable end so that it matches this side here. It keeps everything nice and clean. So with the old cable in the vise here, I was able to open up the old connector and take out my little cable here for the key switch. So I'm going to go ahead and put all this together and crimp it up. Okay, so I now have my new connector crimped on with the battery positive for the key switch. So now I've pulled the heat shrink over it, and I'll just go ahead and use my heat gun to shrink that up, and then we'll install it. You know, whenever I'm working on customers' equipment, when it comes to electrical especially, I always think, how would I do it if it was my own machine? And that's exactly how I would do it on my own. The heat shrink came a little farther down, so I just took the X-Acto knife and just cut it so that we have a nice battery connection there. And this is ready to be reinstalled now. So the end with the key switch wire is installed on the hot side of the solenoid, and you got to remember it bolts horizontally, so I ran the wire facing up so that it can come up, down, and then up to the other side of the battery there. So I'll go ahead and hook this up, and then I'll bring you back. Now it might be hard to see, but I've routed the battery positive up through this hole in the battery tray because there is a plastic grommet on there, so it will prevent the insulation on the cable from stripping away on like a sharp corner like that or something. I'm up under the battery box now, and when you turn to the right, that little triangular gear comes forward. Now that is what would have been arcing out against the battery positive cable, and before it was incredibly long, and now we've shortened it up so that it runs nice and tight up against the bottom of the battery tray, so it won't be hanging down like it was before, which means it shouldn't be rubbing up against that steering piece. So I now have the battery hooked up again. All the cables have been routed away from anything that would, rub against them, such as the steering column or that pivot gear down on the bottom. And when we turn the key on, the hour meter should start. Yep, and the fuel solenoid should click. So we have power at the hot side on the solenoid. There is no intermittent short to ground. And if we turn the key, now that the battery's been charged, it should turn over the engine. There we go. So this thing's ready to go. So let's see if this thing starts up. So when the engine shut off on my customer, it really didn't have anything to do with the amount of time he was cutting. Like he said, every 20 minutes, and then it would get hot, he said, and it would shut off. And it was probably just a case of when he started cutting his lawn, he would get to a point after about 20 minutes where he would have to make a hard right turn, and that pivot gear would come forward, arc itself out against the battery positive, create the short to ground, cut the power to the solenoid, and then also create a very high amp parasitic draw on the battery, which would then drain the battery down. So at that point, the cables would be hot. He'd let it cool down, charge up the battery, and then, probably straighten the wheel out so that pivot gear would go to the back away from the cable. Now you don't have the intermittent short to ground, and everything works again. Well, that's it for today's video. We were able to get the riding lawnmower up and running again, and it turns out that the fuel issue was caused by an electrical issue. But regardless of the issue, my diagnostic process is always the same, and that always starts out with me talking to the customer and going over what the issue is. You know, like my customer said, after about 20 minutes, the engine would shut down, and I had asked him, does the engine shut off quickly or slowly? And he said it shut off slowly, which led me to believe that there was in fact a fuel issue. And we have to remember that if the key was still in the run position, that the coils would not be grounding, so the engine was still getting spark, but it was the fuel shutoff solenoid that was losing power, so it was closing, and now the engine could only run on the fuel that was remaining inside of the carburetor's bowl. And like he said, this engine swap was done about 10 years ago, and it's run flawlessly up until now. So it took 10 years for that little steering gear there to wear down the insulation on that wire. But we were able to get this riding lawnmower fixed up. No complaints from my customer. He was super happy at the quick return. It was, back to him within 24 hours. And I got a nice little video out of it because I thought you guys would be interested in seeing something like that. So if you enjoyed the video, think about leaving me a thumbs up. It really helps me out. You can click here to subscribe and click over here to watch one of my previous videos. I upload every single week, so be sure to stop on by next week. Check the channel out for new content. And as always, guys, thanks for watching.